Hello and welcome to the CCENT journey with me, Ryan. In this video we're going to have a discussion around the physical components. If you need to contact me, you can do that here on YouTube, on LinkedIn or Twitter. So the physical components element comes in two subsections, the first being host, and we'll discuss that now, and next the networking infrastructure. Now host are things that you're more familiar with, things like PCs, tablets, smartphones and servers. Now hosts tend to create or request data. They also tend to terminate data. So an example of this would be you right now at home or at the office on your device, whether that's a PC or a smartphone, and you're requesting as a host this data from a remote host in YouTube for this video. Now, hosts have what we call NIC cards in them. NIC cards come in different forms depending on the host. These two NICs here are actually NICs which go into a PC. On the left we have a wired NIC, and on the right we have a wireless NIC. Your mobile phones, your smart devices, tablets and TVs, etc. will all have NICs in them. If a device connects to a network, to your home Wi-Fi or whatever that may be, it will have a NIC. A NIC stands for Network Interface Card. Regardless of how the physical NIC itself is in the device, the goal of the NIC is the same. Allow you to request and send and communicate with other NICs on a particular network. Okay, whether that network's a small home network or whether that network comprises of a large campus network which spans over multiple sites. Now when we think about connecting our physical NICs or wireless NICs, physically we have things called Ethernet cables. These Ethernet cables, which you've probably seen all around the office or maybe even at home, these are cables that you connect with the end of the cables being RJ45 jacks into the particular device that you want to connect to the network, and then somehow behind the scenes you're able to then browse to your favorite website or request files from another device within or remote from the building you're connecting from. Each device has an array of networking applications. What are networking applications? They're things like Firefox, Chrome, Internet Explorer, web browsers. There are also applications like maybe your Facebook app on your phone, your Netflix app. They're essentially applications which require interaction with a networking device or a NIC. Some software doesn't require networking interaction, like for example Microsoft Word or Notepad. They're not classed as networking applications because they don't require the use of a NIC to in turn communicate with another device, because it's a local application. Okay, now moving on to our next section, which is the networking infrastructure. Here we have access points, hubs, switches, firewalls and routers. Now when we think about the physical component of the network infrastructure, there's actually two subcategories within these. The subcategories are AP, hubs and switches are actually considered access, and the firewalls and routers are actually considered as network infrastructure. Now what I mean by that is the devices themselves, for example access devices, will be where your actual PCs connect into. Okay, whereas the firewalls and routers will be further upstream in the network design. Rarely would you have in a correctly designed campus network a router or firewall actually having host directly connected off this. This tends to not happen in a production network. At home, for example, you have most likely a device which encompasses both switches and routers into a single device. And that single device may also probably have some sort of wireless connectivity in it. It's kind of like an all-in-one. Obviously, we're not talking about a home or small network here. We're talking about a large campus design. And because we're talking about large design, each of these sort of all-in-one device, if you like, with the wireless, the switch and the router, has been split up into different elements. And those elements will actually be placed different in the network depending on their job roles. Now, what's also really important for you to understand and get an idea about is the actual icons themselves, because the icons are unique across the industry, meaning a switch is always presented like this with some arrows on the top. Maybe that's drawn something similar to this, or a router tends to always be a circle with a cross in it. So everyone will have their own way of identifying a networking device, but 9 out of 10 times, if you look at a diagram, you're able to actually understand very quickly what component is actually being represented in that diagram. That's why it's really important that you actually understand and remember not only what individual device actually is and what its job within the bigger picture, but also what that looks like. So when I hand a logical or physical topology to you, you're actually able to decipher what network component fits where. Now, to sort of help to reinforce that, what I've actually done is gone ahead and put together kind of a bigger picture to give you an idea. So let's dive into what this picture may look like. Now we're going to connect together all of our components, both the infrastructure and the host. So first of all, we have our access components. So here we have a single access point and 2 switches. They normally would connect upstream into an aggregation switch, and then from that, again further upstream into a single router, which is most likely protected by a firewall, which connects to the internet. Now, let's think about our host here. Our remote host, let's give an example that host that we'd like to communicate, or maybe we're trying to pull down some files from that remote host, or essentially our destination for this conversation will be out somewhere on the internet. And looking at this diagram, hopefully you're able to understand now where we, as host, actually requesting this traffic, where it would sit and how we'd connect into this. The last bit to pick up on this diagram is the actual cloud itself. Now you'll notice the cloud has been drawn here to signify the internet itself. Now, what a cloud means in the network diagram is kind of one of two things really. Either one is an entity of the network that we essentially don't know about, or most likely it's an entity of the network we don't care about. So let me give you an example. Let's say as network admins, we only cared about this portion of the network. You may warrant the idea of actually encompassing all of this as a cloud itself. The only thing that we care about is traffic going into the cloud, regardless of what happens inside here, is able to reach our destination, and therefore it warrants the use of a cloud. Hopefully that kind of gives you an idea of why you see these clouds everywhere. Okay, so that's what I want to fit in this lesson. We've talked about what a host is, the fact that it actually generates traffic, terminates traffic, and essentially it's the source and destination that we're trying to get traffic to and from across our networking infrastructure. We talked about NICs, network interface card, and the types of NIC, whether that's wired or wireless, and the fact that depending on the device, whether that's a smartphone, TV, or a laptop or desktop, they will all have their own kind of NICs doing the same jobs. We talked about what actually a network application is. We talked about the web browser is one, and things like Notepad isn't a networking application. We had a discussion about networking components. We had a brief look at what the switches look like, what a router looks like, what's a hub, what's a firewall, and the discussion around how important it is to understand and to identify what those icons represent. Then we ended with having a look at the big picture, how all the hosts and the networking infrastructure connects together to achieve a standard or a pretty picture essentially of what the network looks like. Last but not least, I'd like to thank you for viewing. I hope these videos have been informative, and if they have been, please do like and even better subscribe.